Good morning, guys. Welcome to today's lesson, May 21st, perfect cubes. All right, it's all about factoring the sum and difference of perfect cubes, and we're going to talk about what those are. But first, our do now, we see we have to factor 81x to the 8th power minus y to the 6th power. There's no common factor, so we can't divide out a GCF, but this is a clear-cut example of dots. It's the difference of two perfect squares. All right, the reason is because if we were to take the square root of 81x to the 4th, x to the 8th, the result would be a perfect 9x to the 4th, right? Because 9 times 9 gives you 81, and x to the 4th times x to the 4th gives you x to the 8th power. And also, if we take the square root of y to the 6th power, that's a perfect square, which is y to the 3rd, right? Because y to the 3rd times y to the 3rd gives you y to the 6th power. All right, just remember how we write that. We'll have 9x to the 4th, and we'll have y to the 3rd, separated, one of them by addition and the other one by subtraction. All right, perfect squares. Two of them separated by subtraction. All right, number 2, x to the 12th power minus 6x to the 6th power minus 16. Now this is an example of AM because our leading coefficient there, the leading number in front, is 1. Okay, but if you notice what those exponents look like, right, an exponent of 12, an exponent of 6, in our lessons you'll see that this is an example of super AM. Okay, so let's go with we'll talk about how it will be different, but a lot of similarities between standard AM. We need two numbers that are going to multiply to negative 16 and are going to add to negative 6. So remember, they're multiplying to a negative. The signs have to be different. All right, and they have to add to negative 6. So I'm going to open up our parentheses. What are those two values? It's actually negative 8 and positive 2, right? Because when you multiply that, you get negative 16. And when you add those together, you get negative 6. So just showing you how that works out. All right, but it would be negative 8 and positive 2. And now if it was standard AM, right, we would put x here and x here. Okay, but it's not standard AM, it's super AM. So remember, it's that second exponent, that 6 right there, that's going to go to each of these. Remember, because x to the 6th, right, times x to the 6th, that's what gives you x to the 12th power. All right, and you're done. So super AM, if you're not sure, look back at your notes or ask me questions to remind, whatever it is. All right, but x to the 6 minus 8 and x to the 6 plus 2. All right, and one more example of dots. These are two perfect squares. X to the 4th. What times itself gives you x to the 4th? That would be x squared. What times itself gives you 25? Right, that's 5. Set one of them separated by addition, the other by subtraction. All right, just check to make sure you're done. There's no factoring that can continue. And you're done. Okay, so now we're dealing with perfect cubes. We've dealt with perfect squares, now perfect cubes. So what is a perfect cube? A perfect cube is essentially the result of multiplying something by itself 3 times. So for example, 1 times 1 times 1, right, times itself 3 times. 1 times 1 times 1, or 1 cubed, right, 1 to the 3rd power. The result of that is a perfect cube, and that happens to just be 1 to start. But what about something like 2 times 2 times 2, or 2 to the 3rd power, right? 2 cubed, okay? 2 times 2 times 2 is 8. That's a perfect cube. Because if we take the cubed root of that, right? See that little index of 3 in the radical there? If we take the cubed root of that, we get a perfect integer of 2. Okay? Now, what about if we did 3 times 3 times 3? right? Or 3 cubed, right? 3 to the third power. 3 times 3 times 3, that gives you 27. That's a perfect cube. Okay, 4 times 4 times 4, or 4 to the third power, or 4 cubed, right? That gives you 64. And 5 times 5 times 5, or 5 cubed, right? 5 to the third power, that gives you 125. And we can go on and on and on, right? 6 times 6 times 6, 7 times 7 times 7, on and on and on. They'll go on forever, but these are the main ones we have to memorize and we're going to work with today. Okay? And I just want to show you just like how this works. If we were to take the cubed root of 64, it comes to a perfect integer of 4, right? 4 times 4 times 4 does give you that 64. All right, but these are your first 5 perfect cubes. Now this also applies for variable terms as well. Okay, the first perfect cube for x, okay, it would be x to the third power. Why? Because x times x times x, right, times itself 3 times, gives you x to the third power. Okay, the next one would be x to the 6th power. And then x to the 9th power, x to the 12th power, x to the 15th power, and so on and so forth. You might be noticing a trend, but those are your perfect cubes that deal with variable terms. And let's just look at this one. X to the 12th power. Why would that be? Okay, that's because x to the 4th times x to the 4th times x to the 4th, right, times itself 3 times, gives you that value of x to the 12th. Remember, with exponents and you're multiplying, you're adding the exponents. Okay, just to show you where that comes from. Or I could have written it just like I did over here. Right, if I was going to take the cubed root, right, the cubed root of x to the 12th, that would be equal to x to the 4th. Why? Because x to the 4th times x to the 4th times x to the 4th gives you x to the 12th. Okay? So there's some of them written for you here. Okay, to be a perfect cube, the exponents have to be what? So what are you noticing about these exponents? 3, 6, 9, 12, 15. Okay, the exponents have to be multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and so on and so forth. So if it's a multiple of 3 for the exponent, it's a perfect cube. Okay? Now, factoring the sum or the difference of 2 perfect cubes. Okay, factoring cubes always has a binomial and a trinomial factor. So, if it's the difference of 2 perfect cubes, which is this here, a to the third is representing a perfect cube. B to the third is representing a perfect cube. Alright? So, it's when those 2 perfect cubes are separated by subtraction, its factored form becomes this. It's sort of like a formula. Okay, and it is really something you're going to have to memorize when you get to Algebra 2, and, you know, for now. But you can always refer to your notes. Alright? And that's the form that it gets written in when it's factored. All right. Well, same thing here with the addition of 2 perfect cubes. So it could say something like x to the third, that's a perfect cube, plus let's say 64. That's a perfect cube. The factored form of that binomial right there becomes like that. And that looks very, very confusing right now. Doesn't make a lot of sense. Okay? Doesn't make a lot of sense, but as we go through it, it'll make more sense. Okay? And this is really a huge, huge idea here, guys. A and B, which you can see written in the factor form, right? A, B, okay, A, B, all that. That's the cubed root. So when you take the cubed root, all right, just like a square root, when you take the cube root, A and B are what result. Okay, it's kind of like dots. You can see it written there. But guys, as you hear me teach throughout the year, okay, I don't want you to get too caught up in these formulas. All right, right now they don't make a lot of sense. All right, as we go through them, they'll make much more sense. Okay, so let's do one. All right, x to the third power, x cubed, right, minus 8. All right, we need to factor this. That's what the problem will say. Factor. Okay? It's important to recognize that right now, this is the difference of two perfect cubes. All right? Which is a to the third. So let me write this over here. A to the third minus b to the third. And there's a factored form for that. But first, we need to know what is a? What's the cubed root of x to the third power? So essentially, I'm not going to be writing all cube roots and stuff. I want you thinking about what times itself gives me x to the third power. So what times itself, right? Multiply 3 times gives me x to the third. That would just be x. Because x times x times x gives me x to the third power. Now the b value, the second cube root, is saying what times itself, right? 3 times. What times itself gives me 8. Now also, if you're not sure in your calculator, go to GeoGebra or whatever, type in, right, this, make sure the index you set to 3, and type in 8, you'll see what the calculator gives you. All right, but hopefully you know that it comes to 2, right? 2 times 2 gives you 4, times 2 again, that's what gives you 8. Okay, so a and b are representing the cubed roots. Okay, now the factored form of this, once again, you have to memorize this. It comes out to a binomial, a minus b, times a trinomial, a squared, plus a times b, plus b squared. And I'm going to be honest with you guys, I didn't memorize that just now. I'm copying it off another screen. Okay, so as you get started with this, you can just copy it down. All right? But just know for a test in Algebra 2 or whatever, all right, you got to memorize it. Okay? So, let's take a look. Let's substitute now. So our factored form for x cubed minus 8 is equal to a minus b. So a, we said, was x. B is 2, so x minus 2, times a squared, so that's x squared, right, x squared, plus a times b, which is x times 2, right? I just keep referring up here. I keep referring to a and b. Okay, ab is x times 2, which is 2x, right? We wouldn't write x2, 2x, plus b squared. B squared is 2 squared. 2 squared is 4, so plus 4. And you're good to go. You're done. That's the factored form. And we're going to go through 3 more. Okay. If you want, now might be a good time to pause the video and try the next one, but if you want to watch another one, that's fine too. Okay. So let's take a look. Y to the 6th power plus 27x to the 3rd power. Okay, so this is addition now. This is an addition, all right, the sum of 2 perfect cubes. All right, we have to think about what those cube roots are. Okay, but our formula that we're going to use is a to the 3rd plus b to the 3rd. A cubed plus b cubed, 2 perfect cubes. All right, so your factored form needs to look like so. A plus b times a squared minus ab plus b squared. Now it looks near identical, okay, to what we just worked with, except there's just a couple differences with the signs. Okay, positive, negative, whatever. Okay, so let's think about first, what's the value of a? So what times itself gives you y to the 6th power? what times itself times itself. That would be y squared, right? Because y squared times y squared is y to the fourth times y squared again would give you y to the sixth. So our cube root, our first cube root is y squared. And next our b value, what times itself, gives you 27x to the third. So the cubed root of 27 is 3, because 3 times 3 is 9, times 3 again is 27. Now what times itself gives you x to the third, just x to the first power, right? X times x is x squared, times x again is x to the third. So it's all about getting that cube root, and then you can start substituting. All right, so y to the sixth now plus 27x to the third is equal to a plus b, so y squared plus 3x times a squared. So what's a squared? So that's y squared, that's a. We're taking that and we're squaring it. So we're essentially saying y squared times y squared. Okay? That would be y to the fourth power. Now minus a times b, which is y squared times 3x. Remember, the number usually comes first, so it's really 3x times y squared, so 3x y squared, right? That's a and b multiplied together, plus b squared. b is 3x, and we need to take that and square it. So that's saying 3x times 3x, which is equal to 9x squared. Close your parentheses, and you're done. All right, let's try a couple more. 125 plus 8x to the 12th power. Good time to pause the video, try it out on your own. All right, but this would be the sum of two perfect cubes, right? Because 125 is a perfect cube, 8 is a perfect cube, x to the 12th is a perfect cube. So the factored form would be a plus b times a squared minus ab plus b squared. And once again, guys, I'm copying it down. All right? If you need to, go ahead. And at the beginning stages, you will. So what's a? The cube root, right? The cube root of 125. What times itself gives you 125. That will be 5. All right? And now our b value, what times itself gives you 8x to the 12th. So what times itself, right, gives you 8. That would be 2. Right, 2 cubed is 8. And then what times itself 3 times give you x to the 12th? That would be x to the 4th power. Right, because x to the 4th times x to the 4th, right, times x to the 4th, that's what gives you x to the 12th. Okay, so you might have to go off, write it off to the side. All right, but now let's substitute. So this is 125 plus 8x to the 12th. That's now equal to a plus b, so 5 plus 2x to the 4th times a squared, so 5 squared, that's an easy one, 25, minus a times b, which is 5 times 2x to the 4th. 5 times 2 is just 10, so 10 and x to the 4th. And now b squared, so this might be a little tricky. This is saying 2x to the 4th. We need to take that whole value and we need to square it. So that's saying 2x to the 4th times 2x to the 4th. All right, so this is going to be plus 2 times 2, which is 4. X to the 4th times x to the 4th is x to the 8th power. Close your parentheses, and you're done. All right. One more. 64 minus y to the 6th power. So now we have back to the difference of two perfect cubes. So that is written as a minus b times a squared plus ab plus b squared. So our value for a, what times itself 3 times gives you 64. That's 4. And our b value, y to the 6th, what times itself gives you y to the 6th. That's just y squared. So if we have 64 minus y to the 6th power, right, a minus b, which would be 4 minus y squared, times a squared, so that's 4 squared, 4 times 4, 16, plus a times b, 4 times y squared, which is 4y squared, plus b squared, which is y squared squared. So that's y squared times y squared, which is y to the 4th power. Okay. Now, do you notice any forms of factoring left here? This one's a little bit tricky. This is, right here, an example of dots. Those are two perfect squares. All right, and this is a lot to get started. I wouldn't expect you to notice this right away. But if we were to factor that, that would be the square root of 4, right, is 2. So we would have 2 and 2. And now the square root of y squared, what times itself gives you y squared? Just y. So it would be 2 plus y and 2 minus y for dots. And then what about for that trinomial? What if we wrote it like this, right? It would be, if we rearranged it, y to the 4th power plus 4y squared plus 16. Does that look like anything to you? Remember, that's 1 there. Are there any factors, right? Let's just go through this. Can we factor that trinomial? Can we not? Is that AM? Is it super AM? Is there anything that multiplies to 16 that adds to 4? It's good to check for anything that multiplies to 16 and adds to 4. Right, 4 times 4 multiplies to 16, doesn't add to 4. 8 times 2 multiplies to 16, doesn't add to 4. All right, so it's just good to check for. All right, there's not necessarily a way to keep factoring this. All right, but good to check for. All right, guys, this is definitely something that is new. It is a bit challenging, okay, but it's good to see prior to getting into your Algebra 2 classes. These lessons are really incredibly valuable for you to get off to a strong start. You're not going to see anything like this in your Delta Math, at least this week. Okay, remember your Delta Math is due tonight at 8 o'clock. Don't forget it. And that's it. Ask me questions throughout the day and remind if you have them. All right, have a wonderful rest of your day. Delta Math tonight, please. And I'll see you mañana.